Let's discuss one question here. Why the electron affinity of fluorine atom is very less than that of chlorine? You all know that the fluorine possesses 332 kilojoule per mole, whereas chlorine possesses 348 kilojoule per mole. You know, fluorine is the highest electron affinity element among all other elements in the periodic table. We have already learned that among the periodic table, the halogen family possesses very highest electron affinity, and also the periodic trends of electron affinity is that across a period the electron affinity increases, down a group electron affinity decreases. So we will expect that fluorine, as it is positioned in the topmost position of the halogen family, fluorine possesses the highest electron affinity, right? But that is wrong. Experimentally it is discovered that fluorine possesses the electron affinity of 332, chlorine is 348, and following that, bromine, iodine, and aspartame. It's a general trend. Bromine possesses 324, iodine possesses 295, aspartame possesses 270. Because following after chlorine, the general trend of electron affinity down a group, electron affinity decreases. So down a group, electron affinity decreases because of the increase in atomic radii, right? But the issue is with fluorine and chlorine. Why chlorine possesses highest electron affinity than fluorine? That's the question. So let's discuss in detail. So the electronic configuration of fluorine is 1s2, 2s2, 2p5. So we all know that this is 1s and this is 2s2, p5. One more electron. The requirement of one more electron will give fluorine to attain the noble gas configuration or the octet completion, so it will become more stable, right? Due to when a new electron come closer to this fluorine atom, there is already existing electrons are there, right? It will cause an electron repulsion. I have already taken a class on electron repulsion, because when an electron come closer to an atom, due to the very compact size of fluorine atom, because the atomic number is increases, and due to the very small size of 2p, the 2p orbital, the 2p sublevel is very small, so it will contract towards the nucleus. So due to this very contraction, the nucleus will attract the incoming electron towards itself. But when a negative charge electron come closer to the fluorine atom, there is already existing electrons are there. It will force the electron to repel apart due to the light charges, electron repulsion. Also, in addition to that, due to the very small size of 2p sublevel, this incoming electron does not have a possible position to occupy in the valence shell due to this very smaller size. As a result of that, this electron repulsion in the 2p, the valence shell with the incoming electron, it will minimize the attraction between nucleus and this incoming electron due to this electron repulsion. So this incoming electron does not feel that much attraction from this central nucleus of fluorine atom. Hence, the electron affinity of fluorine will be decreases, and hence this value 332. Whereas in the case of chlorine, this is chlorine, right? Whereas in the case of chlorine, the noble gas the configuration, the electronic configuration is neo, that is the core electronic configuration, and 3s2 3p5, that is the valence shell, right? So when an electron come closer to uh, chlorine atom, there is also electron repulsion is there, right? Because electrons are there. But the 3p orbital, the 3p sublevel is bigger in size. Do you know the reason? Because an additional energy level is also there. So it is due to the bigger size, and the second option is that is the speciality of the third period elements. There is D sublevel is there. A vacant D sublevel is there. So this is 1s, this is 2s2 p6, and this is 3s2 p5 and D0. The second is 3d. A vacant d orbital, d sublevel is there in the case of chlorine atom because it belongs to the third period, right? Due to this vacant d orbital, there is enough space is available. So the incoming electron can occupy any position, whether it can occupy in the d sublevel or can occupy in the p level because of its bigger size. So enough space is available. So it does not feel that much repulsion from the already existing core or valence electron of chlorine. In addition to that, I have already discussed that. I have already posted a class on that. There is d pi p pi back bonding. What is this d pi p pi back bonding? So if this is the back bonding, if this is the electron, if this is the p electron, okay, and this is the d orbital, okay. So this lone pair of electron has the tendency to donate towards the vacant d sublevel. Okay, the lone pair, the already non-bonding pairs of electrons already existing in the P5 and S2, right? This lone pair of electron, that is the reason why the incoming electron is feeling the repulsion. That's the reason. This lone pair of electron is also have a position, also have a space to move on. So that is called a d pi p pi bonding. Due to the presence of d sublevel, enough space is available to occupy the incoming electron, and due to the heavier in size. This is the reason. This is the reason how the nucleus of chlorine has that much attraction to pull the incoming electron to occupy any of the spaces. This is the reason why chlorine possesses very high electron affinity than fluorine. So, in the case of fluorine, there is no d orbital. For second period, fluorine belongs to the second period. The second period elements does not have d orbital, but in the case of third period, d orbital is available, that is vacant in nature. So, due to the presence of this d orbital, enough space is available. So, the incoming electron can occupy and it can overcome the electron-electron repulsion. Okay, so this is similarly in the case of oxygen. Why oxygen possesses very less electron affinity than sulfur? Because sulfur is also belongs to the third period. Okay, this is also the reason. And nitrogen is very less than that of phosphorus. Nitrogen approximately zero. Phosphorus belongs to the third period. So d orbital is there, the vacant d orbital. These are the same. The same reason can be given to explain these cases also. Okay, thank you.